Good afternoon, everybody. Welcome to class today. Thank you for joining me. Thank you for joining me, whether you're watching live or you're watching the recording. I appreciate you watching and following along. So this week and next week, right, we have 2 weeks worth of classes here for Module 8. So Module 7 due today, Module 8 starting tomorrow, and going for 2 weeks. And we're going to be talking about dictionaries. So another 2-week module, right? We're getting pretty close to the end of the course here. 2 weeks Module 8, 1 week Module 9. Or maybe 2 weeks Module 9, and then 1 week for Module 10, and then a week for your final project, and we're done. Right, so we are not far away from the end. Well, once again, don't forget Module 7 due today. Your list assignments due today. Have any questions about those? Please let me know as soon as possible. And Module 8 officially begins tomorrow. We start the module a day early with our live classes, as always. And this one is about dictionaries. And I also have another little topic thrown in here. And so we are covering this week and next week. So we will not really have that much to cover this week. So we might end a little early, which will be good. I have a point in my slide deck that I want to get to. And if I get to that point, whenever I get to that point, we will stop. And that'll be all for today. So we'll play that by ear and see when we get to it. And so to start off our discussion of dictionaries, I got another topic that I want to talk about, and that's the idea of global variables. Right? And so one of the things that we've done before, or that we've talked about before, is the idea of a variable being scoped for a function. Right? If we declare a variable inside of a function, it can only be accessed from inside of that function. So for example, if we were to look into a replet here, and I were to create one function, def test1, and declare a variable here and say test word equals hello, and I were to create another function, def test2, and try to access and print test word from that other function, it has no idea what I'm talking about, right? You can see the little red squiggly line. You can see the yellow squiggly line under test word here. You can see the red squiggly line under test word here. If I run this, it's going to just absolutely do nothing, right? Because it doesn't know what test word here is to print that out. And it can't access test word here. This is called a scoped variable, right? When we declare a variable like this inside of a function, the variable is considered to be scoped, which means that it can only be accessed within the function that it's in. Global variables, on the other hand, allow us to access variables in multiple functions. So one of the examples that we say here where we do this a lot is with flag variables or Boolean variables, where we're checking for a true or false condition. We might have different potential outcomes or different functions that might be looking for different things to, turn this Boolean flag to be either true or false. This would actually be quite common in an industrial systems programming. Right, I might have a function to read temperature, and I might have a function to read humidity, and I might have a function to read level, some kind of like water level or something. And if any of these levels get out of whack, I need to turn a variable and turn off the valve or what have you. Right, so in an instance where I need to have a variable that is accessible by multiple different functions, I need to use a global variable. And so when we're talking about using global variables, we have to declare it before we can use it. So in Python, it basically is just as easy as declaring our variable at the class level or at the program level in Python. Now we do see something a little bit different here because we would want to make a distinction between a global variable that is available and a scoped variable that might have the same or a similar name. Right? Because if I have different scoped variables, those are all going to be scoped for their own functions. I can use the same variable name in a different function. So what I want to do when I'm using a global variable is I want to make sure I add my global keyword to my variable call along with the name of my variable to every function that I'm going to use it in. I could just put it at the top of the function. Right, so in this instance, if I were to look back at what we were doing here, I would simply take this and I would declare it somewhere else. Right, one of the things that I might do is put it behind the main gate. So if underscore name is main. Declare that variable there. And so now if I want to use that same variable, so you see here I have test word here and test word here. So if I print test word, and I run both of these functions, in this instance test word is a scoped variable, so it is going to be scoped for test1. So in this case test1 is going to print which is what we get on the output here. But if we run test2 after, the thing to note here would be that, well, if everything was using the same global test word here, right, then if I run test1 first, it should reassign the value of test word and print it out as the same thing. But if I say that this is global test word here in test2, that makes that instance of the variable name distinct from this instance of the variable name. This one is still a scoped variable. This one is the global variable that is declared at program level. So if we run this, we see that we get print out of test1, and we get hello out of test2. Now, if they were both using, that's what demonstrates to us that this test word is different from this test word. Because if we were to also point out that this is global test word, then at this point we are reassigning the value of the global test word. So when we run test2 after test1, we get print again. Right? Because it's reassigned that global variable. Right, so that's showing you the difference between something being global and something being local or scoped, and why we would want to make distinctions between the two. And use this global keyword and put the variable name there just so my program knows the difference. Right? In this case, it's seeing test word and it's saying, okay, like I want to use the local test word that is scoped just to this function. And in this case, it's saying use the global test word, which is the one that's at the program level that's not in any sort of function. Alternatively, although ideally I want nothing outside of my main gate but functions, I could alternatively have this line outside like that, although that is less than ideal based on our best practices. We'd rather keep anything that is not a function behind the main gate. Right, and we've talked about the reasons for that in the past. But that's a new technique that we can use, right? And we might need to use this sort of technique as we are approaching dictionaries and using files and things like that. Because it does get a little, or can get a little challenging. Sometimes we want to be able to use the same variables or the same things in different functions just so we can split our code up and make things into smaller, easily digestible chunks. And sometimes using a global variable is what it takes to do that. Let's talk about dictionaries. And just what exactly is a dictionary? So we've been working with data structures, and a dictionary is a data structure. The current module, module 7, it's about lists. A list is an array is a data structure. A dictionary is also a data structure. Right? And when we say data structure like that, it's just a structure in which we store data. Right? And so when we have looked at lists, over the course of the last couple of weeks, we talked about how a list allows us to basically have a container of containers, a variable that holds multiple variables. And we can access each of the interior variables simply by knowing the address to that variable on the inside of the array. What the index location is of that variable. But it's not the best way to do every single thing. Right? There are instances wherein using a dictionary can be much more helpful. And so let me give you an analogy here that'll help you kind of understand the difference between what we're talking about when we're talking about a list or array versus a dictionary. And we'll use that house on the street analogy again, right? So in a list, we said all you had to know in order to be able to get access to the house is its address. Right? So imagine a street of houses, which in this case is, the stand-in for our array. And in each of the, or you go up to each of these houses and you could just walk right in. There are no locks on the door, nothing that's kind of preventing you from just entering, right? So when we're talking about a list, all you have to do is know the address and you can just walk in and get the data. But a dictionary is a little bit different. A dictionary wants you to know the key. Right? So when we're talking about a dictionary, we are talking about a set of key value pairs. And so now if you have the key, you can walk up and open the door and gain access. But if you don't have the key, you still, you can't get in. Right? You can't get access to that data. We want to know the key in this case. And so keys in a dictionary can be any immutable type. And when we're talking about immutability here, we're talking about any of our primitives, so any numbers, any strings, and we're talking about tuples, which are kind of like lists, but they're immutable. Right? We talked about mutability and immutability in the past. If something is immutable, that just means that it can't be changed. So for our keys have to remain the same. We have to use a data type as the key, which allows our key to be immutable, to be unchanging. And we'll talk more about why that's the case here in just a moment. But the values in a dictionary can be any data type. Right? They can be strings, they can be integers, they can be floats, they can be booleans. They can be any data type, including lists. Right? So we could have a list as a part of a dictionary. And one of the things that we did, last week with lists is that we said, we can put lists inside of lists. But with dictionaries, you can define, you can modify, you can view, you can look up, or delete key value pairs in the dictionary. Any of them. Now, if you are familiar with other programming languages, you might know dictionaries as either an associative array or a hash table. These would be other names for this kind of data structure or a data structure very similar to this. So we said that our keys for a dictionary have to be immutable. Let's talk a moment about why that is. Right? So in terms of mutability and immutability, if something is mutable, it is able to be changed. If something is immutable, it is unable to be changed. And so keys are our reference point. Keys are our point of reference when we're going to look something up. Right? Imagine having a book, and every time you tried to look something up, the page number that the thing that you wanted to look up was on changes. Right? And it's all of a sudden on a different page. Or imagine you're trying to walk into your house and your key is just in your hand changing, reshaping itself. And so in programming, specifically Python, but other programming languages as well, we want to make sure our keys are immutable so that that point of reference remains pure. Right? We can refer to the same point of reference and it gives us the same data. So if we want something from a different point of reference, we have to make something brand new. So on its own, like, it helps prevent accidents, right? Which is pretty important in my opinion. But it can also help with other things. Right? Just making sure you write reasonable code, for example. Because if we lose our point of reference by accidentally changing a key, then we've basically broken the entire thing. Right? If we can't access a singular piece of data from our database or from our dictionary, rather, in this instance, if we can't access a single piece of data because we accidentally changed all the keys, it's no fun. It's not good to try to program. Like that. So before we start to write one, there are a few important things to know about dictionary. One is that keys must be unique, right? Just like, we have a dictionary for every, or just like we have a unique key for everything in our dictionary, we have a unique key for every house. It's the same sort of thing. So if we didn't have a unique key for every value in our database, then it would create a conflict. We wouldn't know what data is what. And we just generally have a hard time working with our dictionary. We can assign to an existing key, which will update the value of that key. So we can change the values of keys. We just can't change the keys. And dictionaries are unordered. So unlike lists, where lists have an index, dictionaries don't have an index. We need to know the key to be able to add item or retrieve items from our dictionary. But we can, as a result, add items in any location to our dictionary. And so we'll talk more about adding and removing things from a dictionary next week. What I want us to do today is just get comfortable with using dictionaries in a program. So let's head back to our replit. And I'm going to delete all this stuff here. I'll do our dictionary example this week as a global, just so we can have that. So behind our main gate here is where I will create our dictionary. And so we start off a dictionary just like anything else. We started off like we would a variable or like we would a list. We just give it a name and add an equal sign. So it is a name. Let's say we call this one test underscore dictionary. And we're going to set it equal to something. And so for a dictionary, the way we outline the beginning and end of our dictionary in Python is that we add curly braces. To get the curly brace, you hold down Shift and you hit the square brace key. It's the key above the apostrophe quote key on your keyboard. But it's these two curly braces that are going to encapsulate all of our key value pairs that belong to a singular dictionary. Right, and we can put as many key value pairs into a singular dictionary that we want. Right, so one of the things that I usually do for this is I kind of end up doing like a little grocery store type program, like a little cash register type program. So we'll kind of go more toward that next week. Let's add like, oh, what would we want to add here? Let's do something for like, maybe we work at a party store. We have balloons, and we want to keep a record of how many balloons we have in stock. So let's change test dictionary here to balloon underscore stock. And this is our dictionary. And we'll put our different colors here. We'll say red. And we can set that equal to some value. Say we have 8 balloons. And I put an equal sign here, and I shouldn't have. It's a colon for a dictionary. Too many different programming languages. So red and 8. So now, if I create a function, we'll start off with just a little function that is just, we'll call it show underscore inventory. This show inventory function will use the global balloon stock variable. And then we can print the call to our balloon stock dictionary. And in square brackets, we add our key, red. And that's how we can access that value 8. We should get 8 here if we call the function. So let's call our show inventory function here. 8. All right, well, let's see what happens if we don't call or we don't add the little square brackets with the key in it there. Let's see what happens if we just print balloon stock. Well, if we just print balloon stock, we see that we get the key and the value. And I'm using just an integer here just as the inventory, but it could be anything, right? Could be a string, could be a list, could be whatever. Right, so let's add a few more balloons here. Let's add our blue balloons. And let's say we've got 10 of those. Notice as I'm making multiple here, I'm adding a comma at the end before I hit enter and go down to the line and add the next one. Green balloons, we have 12 of those. Right, so now we have red, green, and blue balloons. And so now if we were to print this, we can see our entire dictionary. Red, blue, and green. And it gives us the keys and the values. Now another thing that I could do here is I could use the loop to iterate over my dictionary here. So I could say for balloon in balloon stock, print balloon. And so let's see what this does. Right, so for balloon in balloon stock, print balloon. Balloon, again, just being a temporary variable. Balloon stock being our global variable that's referencing our dictionary. Right, so if I run this, I see I get just the keys. Red, blue, and green. And if I wanted to add that, I could say balloon stock, square brackets, balloon. And so this is a way that we can access our keys and values independently if we loop through our dictionary, right? Because if we loop through with our enhanced for loop and we say for balloon and balloon stock, by default, what it gives us is all of the keys in the balloon stock dictionary, red, green, blue. If we say balloon underscore stock square brackets balloon, that since if we know the key, we can unlock the house. We know all the keys here, so we can unlock all the houses and get the data out of it. So what would be the value of something like that? Well, let's say we made a function that allows our warehouse person to manipulate the items in the warehouse. So let's create a new function here. This will be def balloon order. We're going to use our global balloon stock here. That way it'll be referencing. And also I think here in this show inventory, I'm going to put a def current, or not a def, I want to put a print current balloon inventory. So when we print that, it will print balloon inventory, red, green, blue. So in our balloon order, we can maybe ask our users some questions, right? And so we can have a red ordered variable here, and we can set that equal to the integer value of the input of how many red balloons were ordered. And we could do the same thing for blue and green. We'll just copy and paste and change a couple keywords here. So we can get our values. And so now we're asking whoever's using our program, well, how many of this balloon was ordered, how many of that balloon was ordered, how many of this other balloon was ordered. And so since we're using our global balloon stock, we can take this value and we can say, oh, balloon stock red minus equals red ordered. We can do the same thing with blue and green. Right, and just change some keywords. Balloon stock blue minus equals blue ordered, and balloon stock green minus equals green ordered. And let's fix that typo. Green ordered. So this will subtract the value ordered from our inventory and save it in the dictionary. And so when we call, say, show inventory on it, since they're both using the global balloon stock variable, we'll be able to see the updated balloon stock. So now we'll start off by showing our inventory here, and then we will run we can do multiple things here, right? Because we might want to just run this function if balloons were ordered, right? So we could add a conditional where we ask a question, were any balloons ordered? If yes, run this, run this order function. If no, just print thank you and stop the program. Right? We could even do that in a loop so it does it multiple times. Another thing that we might want to do here would be add conditionals to make sure that this number isn't bigger than this number before we do this. So we could add something like that here and just say like if balloon stock red greater than red ordered, then do this. Else print error. Right. We'll just throw that in there quickly as a little proof of concept here. We won't flesh it out completely for purposes of time. Right, because ideally what we would want to do is we'd want to maybe reset the value or pass them, tell them to try again, and put them in a loop and put them back to the top, right? There's all sorts of different things that we can do that we know how to do by now, right? Because we know, the Turing completeness of all of this, the things that we started talking about at the beginning of the semester where we said all programming languages have input, output, the ability to do math, conditionals, and loops. Right? And so at this point, we know how to do all that stuff. We're on to data structures. And so we're just kind of using these data structures to do these things. Right? So we can include this part here as a proof of concept just to see how something like that would work. And we can run it. Right? So we got our current balloon inventory. We just need to add a call to our balloon order function here. Balloon order. So if we run this, it'll start off by showing our inventory, and then it'll start off by asking this question. How many red balloons were ordered? Well, let's say there were 5 red balloons ordered. How many blue balloons were ordered? Let's say there were 2 blue balloons ordered. Green balloons, let's say there were 3 green balloons ordered. And so after that, we get our currently updated balloon inventory. 3 red balloons, 8 blue balloons, and 9 green balloons. Now, this does bring to light a problem that we will cover more in the next module. Right, is the idea of temporary memory and permanent memory, or long-term memory. Because everything that we do in a basic replit here, it's temporary memory. So we can do something like this and do it to where, okay, we've run it through, we have our balloon stock, and we've got the order, and we did the subtraction, and now we have the updated balloon inventory. But if we restart this, since it's temporary, it's just going to wipe what we did out of memory here and replace it with, what it calls when it creates this again. So it'll start back, when we hit that run button again, it'll start back over with red 8, blue 10, green 12, right? It won't remember what we did here because we don't have the ability for long-term storage yet. That's why we have the next module where we're discussing files and long-term file storage. We'll talk text files, CSVs, all that kind of fun. So if we run this again, we see that, it resets our balloon inventory, but that's fine, right? We're learning dictionaries here. It's a proof of concept. We have 8 reds, 10 blues, 12 greens. Now I did add this little error checking here. So if I put more reds than are in our inventory, it's not going to do the subtraction, it's just going to print error. So we have 8 in our inventory. If I say they got 15 reds or they want 15 reds, it's going to let me go because the order that things are going in. I get the error. And I can add something to that that would be more descriptive, like error, more reds ordered than in stock, order not fulfilled. All right, so let's run that again to see that in context. We get 15 reds, 2 blues, 5 greens. Error, more reds ordered than in stock. Order not fulfilled. So 8 reds, 8 blues, 7 greens, because it took the other ones out. Because we didn't have conditions for them. So that's a proof of concept that shows us some of the basics behind using dictionaries here. We will be covering all of this again next week. We'll just be doing more code and working with more things. Right, I've only got 2 slides, I believe, left in my slide deck. So the majority of next week's live class will just be working with code, which is pretty fun. And this is a good proof of concept that gets us the idea behind the global variable and why we might want to use a global variable in this sort of instance. And the basics behind what we can do with a dictionary. Creating a dictionary, and then accessing the different parts of our dictionary to get different things. So next week we'll take what we have from here and we'll expand it out. That's basically all that I have for you for this week. So if you have any questions for me, if you're here with me live, you can put them in the chat now. If you're watching the recording, feel free to, when you get to this portion, send me an email or a Teams message with your question, and I will help you how I can. So we'll hold just a minute here for any questions that anybody might have. I said today would probably be a little bit shorter. We'll wait a minute here until it seems like the stream is getting caught up. No questions at this time. All right. Thank you. So, since there aren't any questions for anybody who's with me today, again, if you're watching later or you think of a question later, send me an email or a Teams message and we will answer it to the best of our ability. We will go deeper into this stuff next week, spend more time in the code. That's all that I have for you for today. Thank you for watching. We'll see you next time.